Good afternoon. Thank you all for being in here. You are in track 3, and this is hooked browser mesh networks with WebRTC and BeEF. And without further ado, the eccentric Frichot.
Hey everybody, how's everyone's DEF CON going? Yeah! Woo! I can't believe you guys are still hanging out here at 6, although I know like a big, 100% of the Australians here have just woken up. So, awesome. If someone's going to find me a beer later on, that would be really, really fantastic. So, my name is Frichot. I'm happy to be here talking to you guys about some pretty fun stuff. I'm one of the co-authors of the Browser Hackers Handbook, and I'm also one of the developers of the BeEF project, or the Browser Exploitation Framework. And in case you couldn't pick from the accent, I'm also an Australian, ex-Australian, Australian ex-Australian. I've just relocated with the family up to California. So what that basically means is I have no idea how hot it is, and every time I get in the car, it's telling me distances that I have no idea what it means. It's like, take the turn right in 500 feet. And I'm like, what the fuck does that mean? Anyway, so what are we going to be talking about this afternoon? There's probably a few main themes that I'm going to be brushing across. Firstly, obviously, is JavaScript, so I apologize in advance. There's going to be quite a bit of JavaScript in this talk. Obviously, client-side security and kind of social engineering testing, and then onto the Browser Exploitation Framework, or BeEF. Hands up here, people who have heard of BeEF before. Awesome. Keep your hand up if you've used BeEF before. Yeah, okay. Keep your hand up if you were authorized to use BeEF as part of a security engagement. Yeah, okay. Awesome. Another one of the themes I'm going to be talking about is obviously problems with browser communication channels. So after you initiate a hook into a browser, how you kind of maintain those comms. Obviously how WebRTC can help, and then finally integrating WebRTC into BeEF. And then I'm going to have a demo of some variety. So let's kick this off. So when Wade, another Aussie, created BeEF, he basically came up with, he just wanted to not pop alert dialogues anymore for cross-site scripting. And people still do this all the time. Like honestly, how often do you guys do engagements and you find a cross-site scripting flaw, and the first thing you do, literally the first thing you do is like alert parentheses 1 parentheses colon. It's the first thing. It's like the knee-jerk reaction to what you want to do if you find a cross-site scripting flaw. And Wade was sitting there going, this means absolutely dick to everyone. Like, it doesn't mean anything. It's useless for developers. It's kind of, the business owners don't understand what it is. And there's so much more that you can do when you have this foothold inside of a browser context. And I guess as the framework kind of grew, and as security testing as a process sort of grew and changed, we started to see people, targeting end users more and more and more. And the browser is obviously a really interesting channel to be able to do that. And obviously as the internet grows, so did the use of browser technology. And this is a really interesting concept, because if you think about it right now, you guys will all definitely probably have a smartphone of some variety in your pocket, which may have one or more web browsers. Those browsers probably have multiple tabs. If you guys have your laptops here, you'll probably have 2 or 3 browsers, all with multiple tabs. And you might have more than one computer, because you'll have a work laptop and a personal laptop. And if you start to break that down, the attack surface for kind of web-based traffic it's enormous. There's a lot of things that can go wrong. Browser developers have done this really fantastic thing where you open up Chrome and it's got 3 buttons, or like 4 buttons or whatever. Like, Chrome's got the burger and the backwards and the forwards and the refresh or whatever, and it looks super simple. Like, my mum can and does use it, but Chrome is seriously complicated. Modern JavaScript is just really, really complicated, and basically this attack surface is ginormous. Wade posits this really interesting kind of risk discussion. And I like to use this example because I think if you kind of think about it this way, it's kind of a bit petrifying. But if you were working as like the security guy inside of your company, And someone came up and said, hey, we need to get your approval to install this application on everyone's computer. And you're like, okay, cool. And they're like, oh yeah, and the primary purpose of this application is to go out onto the internet and just access arbitrary things on the internet, and we can't vet whether or not they're secure or not. And you're like, okay, well that sounds pretty risky. And then they also tell you that the other secondary use case of this piece of software is to access all the sensitive intranet material that you have. At the same time, multiple tabs with things happening in the background. If you knew that we weren't talking about web browsers, a lot of people would say there's no way we should be using this technology. It's very, very risky. I guess another one of the things that we're sort of seeing happen and why we're seeing more people kind of shift to these JavaScript style attacks is thick browser style technology is disappearing. So who here hasn't uninstalled Flash yet? All right, you've all uninstalled Flash. This is Flash Gordon. Have you guys met Flash Gordon before? It's like awesome 80s idol, whatever. And so most of the kind of the thick web technology that we did have, like Flash and Silverlight and all that sort of stuff, is kind of being replaced almost feature by modern HTML5, which, as far as I know, doesn't actually mean anything except for more crazy JavaScript. Lots and lots and lots of JavaScript. So what the fridge is browser hacking. So when I guess we talk about browser hacking, we basically talk about putting payloads in the context of a document object model and then using JavaScript either maliciously or just because that's the way it's meant to work to try and exfiltrate information or find other systems or trick the user into divulging information, using social engineering techniques or whatever. The Browser Hacker's Handbook, and here are the two other co-authors. Michele doesn't like pants, apparently. And is he up there? Yes. I'm so happy that you saw that slide. And Wade actually really likes pants. It's basically focus on various attacks and attack patterns that can occur once someone has injected, I guess, a controlling piece of JavaScript inside of the document object model inside of a browser. Or not necessarily even just within the DOM, but also in the multiple contexts that do exist within a browser, such as within plugins and so on. And in the book, we define this methodology of attacking, which I really, really like, because I think it kind of stages through exactly what we're trying to achieve and what the framework inside of BeEF is actually trying to do to make people who do these sorts of assessments their lives a bit easier. Obviously, there's the initiation of control. So this is by exploiting things like cross-site scripting or stored cross-site scripting or other ways that you might be able to pwn a website and put a payload on there. Could be man-in-the-middle style attacks or phishing attacks or whatever. But obviously, executing a piece of JavaScript by itself is kind of useless unless you can maintain those communications back to your controlling interface. So the next phase is obviously retaining that control. And then at that point, if you have established both of those things in a very, very kind of rigorous and stable manner, you can then move on to your attack scenarios. And then the book obviously goes on to a bunch of other stuff. Most of this talk is just about the retaining of control. So I'm not going to be dropping universal cross-site scripting flaws that I found in anything. This talk does not contain any 0 days. I apologize. It's just kind of looking at interesting channels for the maintenance of comms. So let's introduce BeEF. That's a picture that doesn't really show or help you showing what BeEF is at all. But I guess the idea is at the core of BeEF is that there's a hook.js file, and it's called hook.js by default. You can obviously change that to be called whatever. And once you basically get that JavaScript executing within a document, it will start polling back to the server. So you can basically hook a bunch of resources, they will start talking to your controlling server, and then you can use that controlling server to kind of queue up command modules to execute within the document object model. And obviously you have like a pretty user interface. This is the serious part of the talk, by the way, because I'm a virgin DEF CON talker.
Keep going.
All right, okay. So obviously, right now, the way that BeEF currently maintains its comms is through kind of two and a half primary data channels. The first one is obviously XML HTTP request objects within inside the DOM. And these are pretty much just like dynamic GET requests. Like it's all pretty simple. And I guess the importance comes down to why would you need to be able to retain your communication channels for a long period of time? it kind of comes down to you want to retain that COM for as long as you can, because certain attack scenarios need time to complete. And a really good example that I like to talk about is Michele did some research that he presented at RuxCon a couple of years ago on like distributed blind time-based SQL injection using multiple browsers. Really, really interesting technique. Hello.
Okay, now stop talking.
All right.
All right. So I just want to say thank you to everybody that's here this late, coming in to see a new speaker. That's just fantastic. Give yourselves a round of applause.
Yeah.
How's he doing? Is he doing well?
He sucks. That dude
Excellent.
sucks.
Can you understand anything he's saying? I don't.
No. Dude, thank
All
you.
right.
Awesome.
He said he's going to make a Boilermaker.
Yeah.
All right. Well, anyway, I think you guys all know the drill. To new speakers, to DEF CON, to all the new attendees.
Thank you.
Thank you for coming.
Cheers. Cheers.
As you were.
So obviously, if you're kind of doing these sorts of attacks, the longer you can kind of maintain that communication channel, the more likely it is that you're going to be able to see your results. And sometimes you'll need the time because certain attacks are slow. The second channel is obviously WebSockets, which is kind of like an asynchronous client-to-server channel that I guess is like a new Web 2.0 thing that they've introduced kind of recently. Also another piece of awesome software engineering from Michele. And also DNS, which is a kind of relatively new communication channel. Here's some JavaScript. I'm not too sure. You guys probably can't read this, but basically what this is showing is some of the BeEF client-side JavaScript library, which basically comes down when you you initialize a browser into BeEF. And what we actually do is we just wrap around jQuery, and you can see here this is just like a jQuery AJAX call. And what happens is on a polling period of, I think by default 1 second right now, the browser will basically send a GET request to BeEF, and it'll, if there's a new command queued up, it'll pull it back and execute that module and send back the results. It's not too complicated. That's how Gmail works, pretty much. We basically wrote Gmail. WebSockets are another really interesting way to do this. One of the really cool benefits of WebSockets is that, because they're asynchronous, so there's no more polling. And what you see here, right in the middle there, is basically an event handler for this.socket.onMessage. So what that means is if you kind of submit a command through the UI interface, it'll basically kind of just send through real fast. And there are a lot of different use cases where you'll need the rapid response for that sort of that sort of communication channel. WebSockets are pretty cool. Also, kind of hit and miss depending on if you're targeting a corporate, whether or not it'll get out through firewalls and stuff, but quite often it does. And it's pretty interesting technology in general. And finally, DNS. So this is a relatively new way to be able to communicate from a browser back to BeEF. But this idea is basically there's a couple of encoding functions. So if you have to send data back to the BeEF server, you kind of encode it up and break it down into some payloads. And then you dynamically build images which are put into the DOM, and those images are on domains which are dynamically generated, which I guess are subdomains to the BeEF server itself. So when you start up BeEF, it actually listens as a DNS server. Like right now, you start BeEF, you've got a DNS server running as well. So you can see there the send query function, var image equals new image, image source, blah, blah, blah. Now, there's a problem with each of these communication channels, and if you look at this picture, it's kind of obvious. Regardless of if you're using GET requests, DNS, WebSockets, whatever, all your traffic goes to your server. So from a defender's point of view, that's awesome. You see one browser that's talking to a BeEF server, and then you very quickly find all the other browsers which are talking to your BeEF server, if you're not terrible at what you do. All cows lead to Rome. Now, there's a couple of ways that you can kind of get around this. You could set up multiple BeEF servers. So that could help you obfuscate, I guess, where communications are going to. You could achieve this by having multiple interfaces on a single server. Or is this thing catching my accent at all? Apparently, that's a computer. Like there's not a human there. And that's what I said. And American people paraphernalia. Oh, maybe it knew what I was going to say before I was going to say it. Or you could set up proxy servers. So that's another interesting channel I've seen people use and talk about. Set up some proxy servers and kind of distribute them around the place and have a central BeEF server. There's obviously a bunch of different ways that you can try and help obfuscate the data, but it kind of doesn't help with hiding that concept of a single BeEF server. You could start by reducing your polling periods. So I said by default a second. You could reduce that to a minute. Now, BeEF will still kind of work, but it's not going to be as useful as it possibly could be. We also have evasion and obfuscation extensions within the platform as well, which is really cool. So that basically will, every time you're kind of rendering and building the JavaScript on the BeEF server before it's sent over to the client, it'll be obfuscated, but that doesn't help obfuscate the server. And you can use HTTPS, which it's not going to help. Or you could do something crazy like that. Like, let's make the browsers stop talking to the BeEF server because they don't like BeEF. Like, what? So the first time I started looking into WebRTC, I was like, bullshit, this stuff works. So this is the blurb. It's a free open project that enables web browsers with real-time communication capabilities via simple JavaScript APIs. They made it so that you could web chat to each other. And I don't know, maybe that was something that Chat Roulette were really into or something. And it's actually really, really cool. And then the technology kind of matured and they were doing things like, oh, we can actually make it such that your browser can talk to your VoIP phone as well, because it uses a lot of the similar technology. Hands up, has anyone played with WebRTC before? A few hands. So this, you know, this is not going to surprise you. I'm just yanking stuff. So obviously, for the WebRTC stuff to work, there's three primary JavaScript APIs. The media stream, which is kind of why it was used built in the first place. I don't really touch on that. The RTC peer connection, which is where it starts to get interesting, and then finally the data channel, which I use a lot. So the media stream on this little snippet of JavaScript allows you to kind of set some constraints in what's happening inside of the browser, and then basically kind of use the get user media call against those constraints with like a success and an error callback. And when that happens, because it's trying to access the video, Chrome, for example, will pop up that dialog that says, hey, this site is trying to access your camera. And then if you click yes, your camera will start and there will be a blob stream of data inside the DOM now, which is basically feeding from your camera. Now, by default, that's not going to do anything. It's just going to sit there. Your light will be on, but obviously they've got access to your media. Now, the peer connection interface is where we start setting up connectivity from peer to peer. And here, like furthering on this example, we're obviously establishing a peer connection. We're setting some more event handlers, and one of them is if we get like a remote stream, for example, we then attach that stream to a local div or whatever, so you can actually see the video from somewhere else. I'll go into a lot more detail for how this works in a bit. And then the data channel stuff is kind of what it sounds like. If you've established a peer connection between two browsers, the data channel basically gives you an asynchronous method within JavaScript to send data payloads from browser to browser. This is like a chat example. There's actually heaps and heaps of really interesting users, like example WebRTC websites out on the internet. So if you go on some of the websites, some guys have set up like peer-to-peer file transfer over WebRTC. So first person goes to a website and it has like it'll generate like a unique URL. And you give that URL to your friend and they'll visit the website. Your browsers will establish connection to each other and you can drag and drop files to each other and they don't go through the server. Like, it's actually, the fact that it works is kind of, I find quite surprising. I mean, this is all JavaScript, right? It's freaking crazy. Yeah, and so it really boggled me, the fact that you could have two browsers that were just talking directly to each other. I was like, that doesn't make sense. Browsers are a client. Like, they will send out a request to a port. They're not going to be listening on a port. This doesn't make any sense. Go home, JavaScript, you're drunk. Now, obviously, there's a lot more moving parts for how this works. One of them is the use of things like the session description protocol. So if you've done work in SIP or VoIP, you'll recognize this sort of stuff, because this is how phones figure out how to work on a VoIP network. SDP is needed within the WebRTC peer connection because the two browsers need to know how to talk to each other, because they do talk to each other. Now, WebRTC itself doesn't actually specify how you share this signaling information. They just say that you do in fact have to share it. In many instances, they kind of say there will be a web application that when you first connect to this thing, you'll share signaling data through there, but then after you've established connectivity, you can just talk directly to each other. We actually have used this capability within BeEF for a couple of years. So when this first came out in Chrome many versions ago, the Get Internal IP WebRTC module was created because for WebRTC peer connections and session description protocol to work, the DOM has to be able to determine the local IP addresses of your computer. So that's your IPv4 and your IPv6, plus also your internet IP addresses as well. So Firefox and Chrome have WebRTC enabled by default. So in case you didn't know, like if you're using those browsers, and I think New York Times actually were just pinged on it recently. They were using this technology to find internal IP addresses of LANs and stuff and organizations. It's on by default, so go the internet. This is more JavaScript. That's just an extract of what it is. But basically, what's happening here is down the bottom, the JavaScript is creating a session description protocol offer, and then that will cause the browser to basically kick off a bunch of requests within the browser to figure out its local SDP information. On those events, we can extract IP addresses out of it. So this peer-to-peer stuff is really, really great, but obviously browsers are separated by firewalls, right? Like a browser can't talk to a browser, there's a firewall. This is an InfoSec reactions that says, "In firewall we trust." That's a tiger. No, it's a lion. It's a female lion and some baby that's like completely oblivious. That's a duck. Oh, I can't see from up here. So in an ideal world, this is kind of how the WebRTC peer connection would work. You'd have your signaling through the internet through a web application, in our instance BeEF, and then once connectivity is established, media or data would start flowing between them. But this is never the case. This is generally what we see. Now, WebRTC has methods to get around this. The first of which is stun servers, or session traversal utilities for NAT. And basically, it's a set of methods and technology that provide for the ability for a browser, for example, to be able to get information about its IP address. Google runs stun servers that you can use for free, and I did in my demo. So you don't need to create these exist. They're out there. Now, if the NAT between these two devices is not symmetrical, then peer-to-peer traffic won't work. And so at that point, you're still kind of stuck. The browsers can figure out their IP addresses, but they don't have data channels between each other. And this is where the second component comes in, and this is where the traversal using relays around NAT technology comes in. Turn servers are not necessarily free. There are some on the internet. Some of them you may be able to get onto without paying money. Some of them you'll maybe have to pay money. Depends on how cunning you are, maybe. There's also open source software, so you can actually spin these up yourself if you want. I didn't touch this in my demos because that wasn't the context I guess I was working in. And basically the idea is that these things can take the handshake of a RTC peer connection, and then you can just tunnel the data through that. So the browsers think that they're next to each other, but they're in fact not. More Australians, and people that are kind of Australian. Now, this is all pretty complicated. So to wrap this all together, WebRTC uses this technology called Interactive Connectivity Establishment Protocol, or ICE. And basically, ICE is used to kind of encapsulate these protocols and basically helps you determine the best way to communicate from peer to peer. It's kind of like the Chrome way. Let's make it as simple as we possibly can. So let's set the scene. You're targeting an organization and you've shifted your focus to the internal resources, and you're going to try and exploit their internal web apps and do some fingerprinting and try and do some social engineering stuff against internal guys. And you're allowed to use a tool like BeEF. So step one, obviously hook the browsers. So maybe you found a forum that a bunch of their engineers are on, and you're able to kind of exploit a stored cross-site scripting vulnerability, and you put a JavaScript payload up there or whatever. And then just like normal, you have these two browsers which are talking to your BeEF server. At this point, with the WebRTC extension enabled, you will also be able to kind of start to command them. So at this point, you basically tell one to be the caller, one to be the receiver. The caller establishes its session description protocol information and sends the signaling information back up to the BeEF server as the signaling server, which then gets kind of sent back down to the receiver, who then goes, oh, okay, cool, now I've got this offer. I'm going to build my own session description protocol to get my own IP information and listening UDP ports and so on. Send that back up to BeEF. That goes back to the caller. And at that point, both browsers have enough IP information about each other that they can start actually trying to talk to each other directly. And if all things go well, they do. And then they can also do things like they've established a data channel. So that's kind of after a peer, once the peer connection is established, you have another event handle to kind of pull up your data channels. But the browsers are still hooked. They're still talking to your BeEF server. It's really, really cool that they're talking to each other, but we still haven't gotten around that problem. They're still giving away your BeEF server. There's still obviously a problem. So this is where obviously, because JavaScript is JavaScript, you can use commands that I've put into the WebRTC extension inside of BeEF to tell one browser to command another to go into a stealth mode, as in stop talking to the BeEF server. You can only talk to me now. And then you can obviously use that channel to send commands through it as well. So enough talking. Let's look at this thing. This is going to be fun. I can't see it. What? You wish, man. I've seen you do that. That did not end well. So we've started BeEF. I've got two Chrome browsers side by side here. So the one on the left will be browser 1, and the one on the right will be browser 2. And I've also got the console open. So I've turned on verbose messages, so you'll start to see stuff happen. So this is just one of the default hooks that exists within BeEF. And then once again, you jump back over to BeEF, and you'll see you've now got two online browsers. And if you scroll down, you'll see that we've also determined that WebRTC is enabled. So if that doesn't say yes, this won't work. And it won't say yes in Internet Explorer. And I think Safari it works, I'm not too sure. I'll also, to make this fun, I hooked in a bunch of other browsers. So I got a different Chrome on a different computer. I got a Chrome on an Android as well. Oh, and I did it in Firefox. Now, the first time I did this research, I couldn't ever get this to work. I have now since gotten that, I've gotten past that problem. So Firefox now works fine. So we've got 5 browsers hooked. That's lovely. And we've got some new UI options. So you can right-click a browser and go set as the WebRTC caller, and then select a different one and go set as the receiver and go. And then you can click on a browser, and there's a new tab called WebRTC, and in there you can see the list of your peers and the status of their connectivity. Now in the browsers, there's been a whole bunch of commands and stuff that have come up, and once that kind of connectivity has occurred, you'll see their connected status has gone into connected. So they now have a connection between each other. And I'll kind of walk through what's happening with the peer connection, because the verbose messaging is relatively useful. So this browser on the left is the caller. And the first thing they do is they create the peer connection object with a bunch of settings that we set. And then it basically starts to try and make the call. And to do that, it has to build the session description offer. So this is the signal that gets sent over to the receiver. So it builds this offer, and then it builds a bunch of ICE candidates. So these are IP addresses and UDP ports and TCP ports that I should be able to accept a data channel on once everything is going. So it sends those signals up to BeEF, and then it'll wait for the guy to send the answer back. So obviously the receiver starts receiving those messages, and it's waiting for that offer, because obviously that's the first message that it needs. So it kind of goes, okay, I've got this ICE candidate, I can't use that. And then finally it receives the offer message, and it goes, awesome, I'm now ready to kind of kick off my own peer connection object. It builds its own session description. It sends back an answer, and also a bunch of TCP and UDP ports and IP addresses. This is how you can talk to me. That signal gets sent back. I'm surprised this stuff works, actually. So at this point now, they each have enough information about each other that they can start trying to communicate directly with each other. And once the ICE state goes into a connected or complete state, they're actually connected. So those two browsers they now have an asynchronous data channel between each other. Yay. And what we're going to do is we're going to do like a star. So I'm going to make them all connect to browser number 1. And you'll see slowly that'll grow. Bless you. Gesundheit. Getting Firefox to work was an actual real pain in the ass because they changed their WebRTC implementation maybe 5 months ago. And then I got really drunk and I couldn't fix it, and then I tried it when I was sober and I got it to work. Whether or not that's scientific proof of you get more stuff done without alcohol, I don't know. I'm only a computer scientist. So at this point now, we've basically got each of the browsers connected to browser number 1, and that connection status gets polled and updated all the time. So you can't see that column, but there's like a date. And if we check the WebRTC tab on the rest of the browsers, you'll see that they're connected just to number 1. Now what we can do from here is, which also we couldn't do previously, is we can pull up a module. So for example, detect LastPass is module ID. We can right-click one of the browsers and go execute this module. And this will basically build the BeEF module, kind of change some of the beef.net.send commands, base64 it up, send it over the data channel, execute it on the peer, and send the response back. So browser 1 sent a command to browser 2, detect LastPass. It couldn't determine that LastPass was there. You can do it the opposite way. So browser 2 is running that command against browser 1, and it's gone, yes, I have detected LastPass because the DOM has been influenced by LastPass. And that browser has LastPass. So that's basically a command module dynamically kind of going across the data channel, which is kind of cool. And the LastPass module is pretty interesting as well. But obviously, as you can see on the left, all these browsers are still, they're still online. They're still talking to the BeEF server. So the option that I'm clicking now is command the peer to go to stealth. So what we'll start to see now is each of these browsers will stop talking to the BeEF server, and eventually they'll drop off the online folder. The admin UI has like a timing period of maybe 30 seconds or so they take a little bit before they disappear off that column on the left. So you'll see me refresh the browser. And once a browser is stealthed, it starts sending a heartbeat message back over that data channel, so the peer knows that its mate is still there. So you'll see eventually they'll fall out of the online folder and into the offline folder, except for number 1. So he's the only browser that we're still actively talking to. But they're still stealthed and we can still communicate with them. And this gets really interesting if you obviously jump into the browsers and you pull up the network tab, because you'll see in the stealth browsers they're not making any web requests, they're not making any WebSockets requests, they're not talking to the BeEF server at all. So you'll see I clear the network tab. Browser 1 is obviously actively talking to BeEF, and browser 2 will no longer send any HTTP GET requests. But you can still control it. JavaScript is pretty cool, huh? And just to demonstrate that there's like a bidirectional data channel available, I use the silly prompt command. I'll send that over to one of the stealthed peers. It's not subtle, but it's an easy example. It's one step up from doing an alert dialog. At the moment, running the command modules in the admin UI is still pretty gritty. Like, you've got to put in numbers and do JSON and shit, because the way that we build the actual command module tab inside of XJS is horrible. It's like a horrible nightmare. I want to get away from XJS. I'm pretty sure Michele does as well. This thing's terrible. And you'll see the dialog pop up, and it's like, hey, how you doing? And I'm like, what? Sweet, thanks, DEF CON. And I'll send it back. The response will come back into the WebRTC command results tab. So we've got that data back, and you'll notice that the browser did not send any data at all to the BeEF server. So if you're sitting there monitoring your network egress points, that browser is not talking to the BeEF server. Like always, I like to kind of show one of my favorite BeEF modules towards the end of my demos. I'm searching for the term RIC. That's my favorite. What? That sucks. Yeah. So there's a few things happening under the hood. 10 minutes. A few things happening under the hood for BeEF to kind of behave in this way. I'm going to run fairly quickly over some snippets of terrible Ruby that I've done and some JavaScript. The first thing is that we have to establish some new database models inside of BeEF to be able to handle signaling messages and command module execution and other payloads and other things to communicate the specific RTC stuff to the browser. This is another one of the data models. Then we have done like an API hook. Actually, for those who haven't developed in BeEF, one of the things that I really like about it is it's super extendable. So I was able to basically interact with the hook.js dynamic construction through an extension. So it's one of those things where it's like if you want to play around with some of this stuff, or if you're doing research in sort of like like malicious JavaScript or things inside the DOM, definitely check out BeEF. So this add RTC signal to body function, and the one beneath it, basically it runs every time the hook is generated, and it'll add signaling messages if they're queued up inside of the database. The handlers define some new BeEF server URL endpoints. So these are the endpoints that when the browsers are sending RTC-specific messages back into BeEF, they hit these endpoints. We have some RESTful API. So most of the admin UI you can actually do in fact, you can do it all from the RESTful API. When I first demonstrated this, I was doing it all in the interactive console, but that shit is severely broken right now because of Ruby 2.2 and threads and jobs and stuff. Then obviously you kind of wrap it around BeEF's extension API, so you mount these handlers and you kind of set everything else up to work. Now, the last piece of the pie is the core client-side BeEF WebRTC JavaScript magic. And I'm a terrible developer. Like, I kind of like to think that I know what I'm doing, but if I'm doing software development, like this is mainly me. I'm like on a computer with my elbows, and I'll brute force it with my elbows until things work. It's 600 lines of JavaScript. Seriously freaking kill me. But it actually works. So kudos to JavaScript for letting me suck at it. And in the heart of it is the kind of, obviously brushing over 600 lines of code. Right in the middle is kind of these event handling logic. So if I receive a data channel that is like exclamation go stealth, I'm going to go into my stealth mode and kick off a bunch of timers and do a bunch of other stuff. If I receive an end stealth, I'm going to come out of that state, execute arbitrary JavaScript, execute base64 JavaScript or whatever. Now, there are a bunch of issues with this. This one was an old issue. So there were issues with Chrome and Firefox. I got over that hurdle. Radical. Right at the beginning, during the establishment of the peer connection, there's a reliability option that you use. Now, when I was first doing this, they were recommending it set to reliability false. And this will by default try and use UDP between the browsers. Now, I never had problems with it. So even though I turned off reliability, which is a terrible name for I had peers connected for hours and hours without a problem, even though I had turned off reliability. Apparently Chrome now, you can actually turn this to true and it'll try and use TCP. Now, I haven't played around with that. That could be better. I'm not entirely sure. Obviously, Internet Explorer sucks. Edge does not help. Microsoft, they talk so much about like, yeah, modern web tech, we're embracing it. You can do all your modern web stuff in Edge and whatever. And they're implementing this bizarre subset of some of the WebRTC functionality just so they can bring Skype to browsers. And that's it. And like Chrome and Firefox have had this for maybe 2 or 3 years. I'm honestly surprised. Like it's kind of, it's shocking. Now obviously one other thing is the signaling component requires communicating back to the BeEF server. If a browser is stealthed, it doesn't talk back to the BeEF server. So if the browser starts to move around and its IP addresses start to change, the code currently does not handle that gracefully at all. It's terrible. And obviously you have to touch the BeEF server at least once or twice. So, you know, I'd like to think that you could get away with not having any interactivity with BeEF, but you gotta let it lick you on the face at least once, or maybe twice. Have you seen how long that guy's tongue is? That dog is so not happy. And also, if you're into incident response, this stuff is pretty tricky. So this is another one of the InfoSec reactions that I yanked, and it says, incident response team after a late night weekend incident. Carol! If you're monitoring your egress, you'll spot a browser potentially talking to BeEF. You might not spot the rest of them. Obviously, in my example, it was a star configuration, but you can do some smart things and do logic to kind of pass around. I'm going to talk to BeEF. No, I'm going to talk to BeEF. I'm going to talk to BeEF. I'm going to run a command module, share the results with all my peers. If I lose a peer, it doesn't matter because all the results are everywhere else. So this stuff can certainly be a lot more advanced than it is right now. Not that it matters, because VirusTotal doesn't pick up on the default BeEF hook anyway. From time to time, this might hit a 1 or a 2, and then we change the date in a file and it stops working again. You know, same thing, there was some guys that did a Chrome extension to detect BeEF because there were certain signature patterns in the cookies that were done. Michele, within 4 hours or something, he's like pushed the change and it's gone. They make a change and then 2 hours later he makes another change and they're just like, this is ridiculous, like we're not doing this anymore. Because really we're just doing what JavaScript is meant to do. Now obviously because of those issues there's a bunch of things that I would like to see happen in this space. Handle remote peers better. There's open source turn implementations. It'd be interesting to actually integrate that into BeEF. So if you're behind firewalls, you kind of would be able to do it. Handle those peer termination events better. Like there's stuff that you could do there, which I'm not doing. Obviously round robining the peers. And I've actually run this in a bunch of corporates and I'm always surprised that the traffic quite often does make its way out. Now I haven't extensively researched that behind maybe more active proxy style environments. That could be interesting. And that kind of comes to the end of my talk. I need to call some shout outs. Wade, who's not here, who's a freaking lovely dude. Michele, who is here, he's lovely as well. Obviously everyone that helps with BeEF, and there's probably people in the room or at the event that have contributed stuff to BeEF. Come and say hi, I will buy you a beer. I fucking love all you guys. Everyone that helped with the Browser Hackers Handbook as well, because while there was the 3 of us that kind of managed it, there was tens of other people that also helped contribute. Shout outs to my old dudes in Australia, everyone I talk shit on Twitter with, and my wife and baby, thank you very much. I think I've got 2 minutes for questions. So if anyone has a question, I'll probably answer half of a question. Just yell, I'll repeat, I can hear you.
Okay. You mentioned in your talk you recently moved from Australia to the US.
Mm-hmm.
Do you prefer the term traitor or betrayer?
Okay, so the question was, Christian, you're really handsome. How do you maintain those stunning good looks and work on open source software and work and have a family and shit? And it's basically just beer and eating terrible. Any other questions? Yeah, over there. Well, okay, so the question was, what tool do I use to debug JavaScript? That's a really interesting question. So Rapid7 did an open source security matters thing last night or the night before, and I did a little BeEF talk, and I basically said most of the JavaScript inside of BeEF is kind of 1990s JavaScript. ECMAScript 6 and all the modern stuff that's coming out in JavaScript, we're not really using too much of that. We're also like not doing a lot of dynamic loading using a lot of the technology that people use, like Browserify and that sort of stuff. We don't test, I think some of the guys might use tools and stuff to help them debug JavaScript. I debug it by basically like console.logging. and opening up a console log, which is terrible. I'm getting thumbs up. It's the terrible hack way to do it. I think that's what he's trying to say. We know, I think it's just one of those things that because mostly people are trying to squeeze stuff out in a really short period of time, a lot of the testing framework is not as mature as it probably should be. And like the use of XJS, for example, to me is a really big indicator that there's not been love as much for the project over the last couple of years as it probably should be. Michele's been doing some crazy cool shit with like the auto rules engine stuff. I'm not too sure if you guys would have seen that. If you want to talk to him about it, definitely hit it up. So feature-wise, that's probably the biggest thing that we've seen over the last couple of years. But no, I'm terrible. And I freaking love and hate JavaScript. I don't have any good way to debug it. Ruby side, I'm also the same. I'm actually like, I just put puts everywhere. So I'm shit at that as well. And these guys were all like, use RubyMine, like do debugging properly, you plebeian. And I'm like, I computer really good. Fuck it. Any other questions? Oh, no, I'm out. Guys, thank you so much.